Hi, and welcome to this webinar on Internet of Intelligent Things. In this webinar, I am going to discuss how these tiny devices which we are using every day are becoming more and more smarter every day, and how they are having an impact on our day-to-day life. Um, Before I give a brief introduction of myself, just to set some house rules. Welcome everyone to this webinar. Um, you have no camera visible, so don't be worry about that part, that it would be not streamed live. And if you are using the camera, please turn it off, just to save bandwidth on that. The chat function is not available in the webinar, but there is Q&A session available. So if you have any questions, please feel free to post it there, and we will have two parts between this webinar where I will try to give you answers to your questions. Okay. Okay, so let's start. So my name is Ali Intizar, and I am assistant professor in Dublin City University in the School of Electronic Engineering. A bit brief introduction. Here you see a bit younger version of myself. So I started in Dublin City University last year. So I am here teaching in the School of Electronic Engineering, but I have been involved in research in Insight SFI Center for Data Analytics for last 8 years, previously at NUIG and now at TCU. I did my education from Vienna in Austria, where I did my PhD in databases and artificial intelligence. And originally being from Pakistan, I did masters in computer science from there. So let's start this webinar with a very basic question, and that is, what is the internet? I will give a small pause to let you think, what is the internet? At least all of us know that we are using internet at this moment for this webinar as well. And this is some activity which we are doing every day. So in the exact definition of the internet is, it is a network of computers. So we have computers which are connected to each other in order to make connection, in order to transform some information. So we have a network of computers which are connected together. And this network is not small in one geographical region, but it is spread across the world. So we have a network of computers which is spread across the world. And how it is connected across the world is using different cables, satellites, wireless communication systems. And if you see on the right-hand side here on the map, this is a map of the undersea cables we have across the globe. And this is a huge infrastructure which is available throughout the world, throughout all our globe, and it makes us connected with the internet. So this huge infrastructure is enabling the internet, which we are using every day, or almost every day. And it makes the connection of the computers in such a way that they can transform the information from one place to another as they wish. So the internet is a network of computers making all those computers interconnected. How it works? So a simple things what we do, for example, we are chatting on any messaging service, or we are using internet to transfer some information. So we have initially a sender of the information, a person who is sending this information. And then we have a network, a huge network of cables, infrastructure available, which is responsible to collect the information from the sender and then send it to the receiver. So when we are using internet, If you see the information we are sending from one place to another place, underlying is a huge infrastructure available which is making all these devices connected. However, they are very efficient and they are very speedy, so we don't feel any delay. Even in this webinar, the way I am speaking at one place and you all are listening, we are broadcasting and you are listening, all this is happening because of this underlying infrastructure, which is helping us to move the information from one place to another. So looking at the evolution of the internet, I could be biased because I am in the STEM field and I am more enthusiastic about internet and web technologies, but I believe it's one of the biggest invention we have in the late last century, and it is have revolutionized the way we live our day-to-day life. So all it started in 1960, we can say 58, 62 with the introduction of ARPANET. And the whole idea behind ARPANET was how to make two computers interconnected. So we want to make a connection between two computers or multiple computers. And ARPANET was the first implementation where multiple computers were joined together. Things keep improving in terms of performance, in terms of the increasing the number of connected computers, till the biggest revolution, the second phase came in the internet was World Wide Web. Nowadays, we use the same terms, internet or World Wide Web. People think they are almost same. They are to some extent, but web is a sub-variant, a smaller part of the whole internet. And when the World Wide Web came, it was an explosion of information. So we have a lot of information available on the web. Every time when we browse on internet, we are mostly accessing the World Wide Web and collecting information from there. In this webinar, I will be mostly talking about Internet of Things. So not only the internet or World Wide Web, but we will be moving towards Internet of Things. So if we look in the history of the evolution of Internet thing, it all started before internet. It was human-to-human communication via telephonic system, our maximum SMS service, till the World Wide Web came, which we call it Internet of Contents. So we have a lot of information which is available on different computers, and we are assessing it globally through these websites, through this all messaging services, emails, all the videos what we watch. They are all called Internet of Contents. So there are different contents of information available, and we are assessing it. Then the next phase of web came in, you can call it the time when we call it .com bubble, where we start building Internet of Services. So internet, the web itself was useful to share information, but then the businesses came in, e-commerce portal keep coming, where we have business services available for people to use it through internet. And lately, in early this century, we have another evolution in internet. We call it Internet of People, particularly coming with social media. So we have social networks available, which is using internet as the base technology, but it's making human-to-human network. So it is, again, combining the information we have from internet, and then we are using, at the same time, Internet of People, which is making a social network of us. And we believe that the next biggest evolution going to come in future, it's already there. It will be also have an impact for a long time, which is machine-to-machine communication. So we have internet infrastructure available. We have all the information available on the web. We have also a network of people where people are helping to generate contents, share information through social media. And then comes the Internet of Things, where machine will start to talk to each other. Machine will start making decisions autonomously. They will collect information from web. They will collect information from social networks, and this will help them to make better decisions for us. So before I go in depth of Internet of Things, I have a simple poll question. And I'm asking here from you is, could you tell me how frequently are you using internet? And at the same time, how frequently are you using Internet of Things? So poll is there. I will pause for a couple of minutes, waiting for you to answer this question. Okay, thank you very much. Quite a few questions coming. So here we have answer. So as I expected, majority of you are using it every day. A few are having a 2% are getting some break, and then 1% never. I don't believe that, because anybody who is on this poll, who is voting for this poll, is on internet already. So we have used it. Okay, so I have next question, which is about Internet of Things. So share results. No. Okay, yeah. So next question, I'm asking this similar question almost, that how often do you think you use Internet of Things? Okay, just wait for a few more seconds before we close it. Okay, and just here we have results. So we have almost 50% of you who said we have no idea what is Internet of Things. We have some good early adopters, at least 30% who are saying they are already using it every day. We have 2% who said never. So we hope by giving by more introduction of Internet of Things, by the end of this webinar, I might be able to change your opinion on I don't know what the Internet of Things is. And maybe some of you realize that you are using it more frequently than you suspected initially. Okay. Okay. Okay, so let's start with IoT. So what is IoT? So I believe that it is the next evolution of the internet. It has revolutionized the way things we do on the internet right now, because we have moved from information to social networks, and now we are looking into machine-to-machine communication. And if we look around, IoT devices are everywhere nowadays. All those devices electronic devices which you use every day, they are categorized, majority of them could be categorized as IoT devices. And when we say IoT, it means that it is a thing, any electronic device or any physical thing. When we have a mechanism to connect it to internet, that becomes an IoT. So if I have a mobile phone, which is a simple mobile phone, if I have a mechanism to connect it to internet, that's already an IoT device. So if you are using a mobile device, you are somehow contributing to IoT. But it is not only with the computers or mobile phone or smartphones, it is also about all the devices. For example, a lamp, a camera, a clock, a bulb, a washing machine, a refrigerator, or a smart car. All these devices, any of these devices which has a capability to connect to internet, is an IoT device. It becomes a potential source of information for us to collect data from there, and based on that, make a smart decision. So this was a term coined by Cisco Systems in early 2000s, and they call it Internet of Everything. So we have Internet of Thing, but that was still ambiguous. And with the Internet of Everything means anything which we have a physical object available, which has the capacity to connect to internet, is part of the Internet of Thing network. As you might suspect, with IoT coming on board, there is a huge potential of a lot of sensors or information available, which could provide us information, which could also provide us some mechanism to collect data from them, and then make some useful decisions on top of that. Think of a typically when I'm giving this lecture to a general audience, I ask this question: how many sensors do you own? And I usually get the answer is saying, I don't know, or I have very limited idea, maybe one or two, I have some device which have sensors. But if we look around, for example, a smartphone, which many of us have, it on average, it has more than 15 sensors available. So we have already, you own 15 sensors in a simple, smart, basic level smartphone. Think of a smartwatch. All these modern smart watches or fitness bands which are available, they are fully equipped with a lot of sensors. And they are sensing the information related to our temperature, related to our heartbeat, how much steps we are doing in a day. All this information is recorded using these sensors. And then, since they are smartwatches, they are even capable of sharing it with the external sources on the internet. So you can collect this information, you can share it on the web. Smart home. We are already witnessing some implementation of smart homes where either it's a smart doorbell, either it's a modern CCTV system, or it's a simply changing the light color in a bedroom or turning them on and off. All these are smart sensor installed part of a smart home. But a rough estimate is that on average, when a smart home is installed in any home, it might have more than 1,000 sensors installed. Same goes with the smart buildings. Look at our airports, train stations. They're all to some extent equipped with infrastructure to collect this sensor information. So when I'm talking about sensors, so they are collecting information, and each sensor becomes an IoT device, because when it's connected to internet, it becomes an IoT device. It's a sensor collecting information, sharing it on the internet. A modern vehicle nowadays, it on average have more than 600 sensors. And I'm still not talking about autonomous vehicles. I'm talking about just perhaps an electric car, modern car. It has more than 600 sensors. Even the old car which we are using have some sensors installed. So the key question becomes with IoT that these are a lot of sensors available, how we can make them connected so we can have better information, better decision-making power. So in terms of sensors, when we see, it's not only about the sensor we install in our infrastructure, it's also about designing those sensors. So here in DCU, in electronic and computer engineering, one of the biggest challenge which we are trying to address is how to make those sensors smaller. So this is a big question which is being posed by the community, particularly in the electronic engineering, how we can make these small, tiny devices so small that they are easily fit for the purpose. So give you one example here. So this is a tiny sensor which has been developed for medical reasons, and it could be implanted by surgeons for the brain surgery. And then once it's done its purpose, it has collected information which was needed to observe the improvements, it can dissolve itself. Same goes with agriculture. There are many sensors which are biodegradable. So you put the sensor there, they do their purpose, and then they become dissolved part of the nature without having any carbon footprint. What this is world's smallest camera, very recently built, and you can imagine the size of it. There are some sensors available which we can even use in on our teeth, and they can track the movement of our mouth. They can track the hygiene conditions. They can track the different diseases if there are any bacteria being developed, tooths are decaying. All this information could be observed by these tiny sensors. And then comes the situation where we have smart devices, let's say a smart toothbrush. And when they work together with those sensors, install your mouth to find out the right course of action, which area of your mouth needs cleaning. And when we talk about these small devices, these small sensors, they are very tiny. At the same time, they're becoming very cheap. So there is no much cost involved in installing those sensors. Another example here on the bottom left-hand side of the slide is a pigeon has been used or had volunteered itself to help us to collect data regarding the climate change. So in UK, this was a case study where they developed a small kit which is collecting information about CO2 levels, about moisture in the air, pollution in the air quality. And then they install those sensors on top of pigeon, so they are very lightweight. And as the pigeon move from area to area, they were able to collect this information. Then the next step, when we have these sensors developed, particularly this is enthusiastic, many students nowadays in school very enthusiastic when they look about robots. So robots is a machine. And the way we as a human work, we have senses. We are able to see, we are able to smell, we are hearing the information, taste, touch, all these senses which we have in our human body. Robots have sensors to replace those things. So robots work with the piece of information they collect through these sensors. So there are sensors available to observe the air pressure, let's say. There are sensors available which make you the feel of pressure only to feel of touch. There are microphones are basically a hearing sense for robots. Cameras are eyes for robots. So there is a good set of complementary to and for the robots to include those sensors in them to make it much similar to the senses we as a human have. And if we look at any IoT systems, they are designed in a similar way, where we have microcontrollers which work similar to the brain of human, not exactly, but at least have the ability to process information and come to a conclusion. We have cameras, we have microphones, and then we have a network of communication. In IoT, I was talking about Internet of Things, which helps us to communicate this information throughout. So whenever I have to build an IoT system, how we build those IoT system is simply we need to have sensors. So we start with the sensors. So anything which can capture the information around their environment is a sensor. Whether it's a light which automatically turns on based on motion movement, this is a sensor. Whether it's a camera, which is CCTV camera installed outside a home or a building, that is already a sensor. With IoT, the first step comes how to connect them to internet. So once we have the sensor, the next step is how we can connect it to internet. If I can connect them to internet, that becomes a source of information which is not bound to one place, but is available for the whole globe if I desire to. And then these sensors are collecting information. So comes how I can gather this information from these devices. How I can share them. So how I can share this knowledge with multiple devices so I can come to a common knowledge base, which is a wisdom of the crowd. So you have one sensor installed at one place, much like we do as a human, and then you have a collective information. And when we have this collective information, we can analyze it. And when we analyze it properly, it helps us to make decisions. And if we make good decisions, it also helps us to automate the system. And there comes the IoT into play when it's a machine-to-machine connection. They are talking to each other, they are analyzing the information, and then they are making some decisions. You might have observed something simple in home refrigerator. So if it is automatic, sometime when it reaches its required temperature within the refrigerator, it stops operating. And if you open the door for a while, it starts again itself when the temperature is gone above the threshold was set. This is an automated system already developed, which is collecting the sensor information, which is the inside temperature of a refrigerator. And whenever it goes to a certain level, it automatically updates itself. That's already an IoT system when it is connected to internet. So if we have a smart fridge which can connect to internet, it is an IoT system. And then we are talking in IoT is not individual system for refrigerator, but we are talking a system of systems where your washing machine can talk to your fridge, where your fridge can talk to your phone and inform you about the stock level in your fridge in terms of food, and or in some cases it can also place an order on your behalf that you are low on bread, it's time to order it online. So I hope with this discussion you might have get a rough idea what is an IoT system and how they are helping us in our day-to-day activities. Another challenge which I am really focused on here in electronic and computer engineering in DCU is making those small devices intelligent. So we are trying to mix two fields of science and technology. One is Internet of Things, which are these tiny devices. Second is artificial intelligence, and how we can put them together. So in some cases, all the sensors which might be collecting sensitive information can make decision locally. So you don't need to share your information on the internet. You can collect the information locally at the device level, and you make them smart so they become independent to make their decision by themselves. Sorry for the bit technical text here, but the whole purpose of this challenge which we are trying to address, and it would be there in future for next, at least for 1 decade, would be how to make these tiny devices intelligent and then collectively act together to build nice systems for IoT, performing different action for different domains. For example, for smart cities, you might have witnessed somewhere already where the smart cities are equipped with parking place finder applications, which are sensing different parking places and giving information about how much parking spaces are available. Or waste management, where smart bins are installed, and when they start to overflow, before even starting to overflow, they trigger an action and inform somebody that it's time to collect the waste. With Industry 4.0, all the smart factories are working on how we can use IoT to collect information, connect the factories, and right from the beginning when we place an order for a product till we actually receive it, the product delivered at home, how all these things could be connected. Smart farming, where there are sensors being installed in to monitor the soil moisture, where sensors are installed to monitor the health of animals in a farm. And they collect this information continuously, they analyze it, and then it helps us to make decisions. Okay, so I hope I managed to give you a rough idea about what is IoT and how it is more prevalent in our day-to-day life than we suspect. It is all around us. I will look into now questions, but I have here a couple of videos which I'm going to play and it will give you a rough idea about what the Internet of Things is and how it works. I know Zoom has a big issue with videos when they are broadcast, they lag. So I have given a link of YouTube here, so you can open that link and you can watch that video there, but I'm going to play here as well. And there is also a barcode available, so you can scan it on your computer, on your phone, and you will have the URL where it's on the YouTube, this movie is. I'm going to play here, but if you are if you are experiencing a bit lagging, you can open it on YouTube, but then watch it on YouTube with mute, so you don't have two sounds coming.
The Internet of Things is changing much about the world we live in, from the way we drive to how we make purchases, and even how we get energy for our homes. Sophisticated sensors and chips are embedded in the physical things that surround us, each transmitting valuable data that lets us better understand how these things work and work together. But how exactly do all these devices share such large quantities of data, and how do we put that information to work? Whether we're improving the production of a factory, giving city residents real-time updates on where to park, or monitoring our personal health, it's the common Internet of Things platform that brings this diverse information together and provides the common language for the devices and apps to communicate with each other. The process starts with the devices themselves, which securely communicate with an Internet of Things platform. This platform integrates the data from many devices and applies analytics to share the most valuable data with applications that address industry-specific needs. Let's start with a simple example, a car. After taking a long road trip, Rebecca notices that her check engine light has come on. She knows that she needs to have her car looked at by a mechanic, but is not sure whether it's something minor or something that needs immediate attention. As it turns out, the sensor that triggered Rebecca's check engine light monitors the pressure in her brake line. This sensor is one of many monitoring processes throughout the car, which are constantly communicating with each other. A component in the car called the diagnostic bus gathers the data from all these sensors, then passes it to a gateway in the car. The gateway integrates and sorts the data from the sensors. This way, only the most relevant diagnostic information will be transmitted to the manufacturer's platform. But before sending this organized data, the car's gateway and platform must first register with each other and confirm a secure communication. The platform is constantly gathering and storing thousands of bits of information from Rebecca's car and hundreds of thousands of cars like hers, building an historical record in a secure database. The manufacturer has added rules and logic to the platform. So when Rebecca's car sends a signal that her brake fluid has dropped below a recommended level, the platform triggers an alert in her car. The manufacturer also uses the platform to create and manage applications that solve specific issues. In this case, the manufacturer can deploy an application on the platform called the Asset Management System. This application oversees all of their customers' cars on the road, as well as all the parts in their warehouses. It uses the data from Rebecca's car to offer her a potential appointment time to service her car, directions to the nearest certified dealer, and a coupon for the service. What's more, the app will ensure that Rebecca's brakes are covered under her warranty, that the correct replacement part is ordered, and then sent to the dealership so it is ready when she arrives. But the manufacturer's analysis does not stop there. They have also deployed a continuous engineering application that tracks not only Rebecca's car, but hundreds of thousands of others, looking for ways to improve the design and manufacturing process of the car itself. If the same problem in her brake line crops up in a critical number of other cars, the manufacturer uses applications custom built for the automobile industry to pinpoint the exact problem. They can see if these cars were made at the same factory, used the same parts, or came off the assembly line on the same day. So what do all these pieces add up to? Streamlined inventory management for the dealer, a better, safer car from the manufacturer. And for Rebecca, it means she can be back on the road faster and get to where she's going safely. All thanks to the Internet of Things.
Okay, I hope it worked fine for most of you, or in case you were able to watch it on YouTube through this barcode or following this tiny URL. Just I'm quickly going to answer a few very good questions I have in the panel. So one question is, how is a lamp or other object connected to the internet? Very good question. So any lamp which we are seeing nowadays in our most of the homes, they are not smart. So there is not an easy mechanism to connect them to internet. But you might have heard these smart lights, smart lamps. They are already available and they are not much different in terms of the cost for the normal lamps we are using. And when we have a smart bulb, a smart light, they are capable of connecting to internet. So whether it's through a smart switch installed to turn that lamp on and off, which can collect the information related to how to turn it on, how to turn it off, what's the expected level of light we need to turn it on, or do we need to dim it. All this information is collected either in that smart bulb or in the smart switch. And when they are put together, they become an IoT object because they can be easily connected to Internet of Things. And normal everyday right now we are using most of they are, I call it dumb light bulbs or lamps, but sooner hopefully they are going to be replaced by smart lights. Um, then I have a question which is about if this example I gave about sensor in the brain is going to dissolve, what doctor was basically checking in that case. So think of a brain surgery as a very complicated process. And then when you have closed a successful surgery, you want to monitor the condition. So like a normal surgery, you have a visit to a surgeon, which is asking you a few questions, how you're feeling, how it's going. With brain, it's not easy to scan again and again and find all this information. So you can implant this sensor which start collecting the information. And the purpose of that is to see is the recovery is going good or if we need to have another surgery. And such kind of sensors are usually designed that they collect information for first 2 3 days and then they can dissolve. So if they have served their purpose within first few days. The third question I have is a hypothetical question which says that what if AI takes over everything? This is a early panic questions. I am mostly on technical side, so I am unable to answer the philosophical side. But at least I can tell you there is a lot of work needed to bring those machines to the at least at par level of intelligence we have as a human. So this is not easy to make decisions based on their own. We can see in the fictional movies. Perhaps when you join the STEM um, field later on, maybe in next 10 years, maybe in few years, we might be able to see the intelligence coming in the machine to a level where they can make some autonomous decisions, but it is still not to a level where we can say that artificial intelligence is going to take over us as a human. They are going to do the task for us, and my opinion is they will do what we ask them to do. Okay. Okay, so one question is how we can disable those sensors. Because, for example, when I'm wearing a seat belt, its seat belt is on, but it still keep telling me that seat belt is not on. So some sensors are installed to help us in a way. For seat belt is very important, and there is a sensor installed in the hook of the seat belt which tells us that when it's clicked properly, it tells us that somebody is wearing seatbelt. So it is a combination of one is the pressure or weight sensor, which judges that somebody is sitting on the seat. And the second is that, is it locked properly? We can disable, but there are some application, for example, for smart home, if I have a CCTV camera, I don't want to share it on internet. We have the possibility to turn it off. But in some cases we don't, which is like it is important features. So it is still possible. But why would you do that unless you get it checked if the sensor is faulty? Okay, so I will come back to other question later on before I move into some examples. So I give you some examples on IoT. So these are the top 10 applications listed for IoT in last year. First one comes the connected car. We are seeing many cars are coming now. It's branded as smart vehicles, particularly the electric vehicles. They are equipped with loads of sensors. But the real power of this connected car comes when we are able to make car connections with each other. So think of a scenario where a car is on a highway or on a motorway, getting too close to another car and automatically sense it and keeps a safe distance. Think of a scenario where cars coordinate with each other about potential traffic jam coming ahead. And these are not science fictions, they are already IoT is helping in cars to make such decisions. Smart homes. So whether you have a CCTV camera, which is potential to connect to internet, whether you have a smart doorbell, or whether you have a smart fridge which can connect to internet, you are already a user of a smart home. So you are using IoT for your smart home, where you have a power to control either the light, turn it off, either switch off your burglar alarm, or look into the doorbell and see who is at the door. You are already using an IoT application. Smart city. We are witnessing every day smart cities are getting more and more smarter with many sensors installed, and these sensors are working to collect information, and then we have services which are combining data from different places to help us to make good decisions. Smart farming, particularly nowadays, drones are used to give fertilizers or water the plants. All this kind of information is collected through IoT devices. When is the time to fertilize, or when is the time to water the plants? And then you have machinery which can act on your order and perform those tasks. Smart grids already are in place in many of the modern Western countries and cities, where grids are not only working to supply but also purchasing the electricity in case you have a solar panels. Factories are getting more and more connected, and they are making products at multiple locations digitally through just exchanging the information and then building the products for us. In retail, you might have seen an early adopters of IoT, where some possibility to scan some items through a device which is connected to internet, and it might give you some reminders about what product you are lacking in your home. You can buy it, or it can also give an alert to the retailers that they are low on stock on some products. We have also potential in the supply chain management. Particularly in COVID, it became very apparent we need to have sophisticated maintaining the supply chains. IoT is already helping there. So trucks are equipped with sensors. We know their location when they leave the factory, how long it takes them. Looking at all this information gives you a clear picture about the supply chain management. Traffic monitoring. We might have already noticed in the busy rush hour some of the traffic light duration change automatically. This is through IoT. So we have sensor installed in traffic lights. We have sensor installed to monitor the queues, how long they are on a road. And based on that, they make smart decisions to change the timing of the light, how long to keep it green on one side and on another side. All these are IoT applications which we are using every day, and they are going to become even more prominent in future when technology is going to advance further and further. Okay, I just put some green tick here. It's not that I endorse for these kind of application, but these are applications which I, together with our team in electronic and computer engineering, are already working. But there are some other possibly all of these applications, and there are many more potential applications which are being used by people every day. Okay, that brings us about the one more video I have, and that's the last video I have, and same philosophy here. Look on the tiny URL. You can type it in your browser if you want to see it directly. You can scan the barcode, and I'm going to play it now. Okay, thank you very much. And just a couple of quick questions. Very good question on how to create a sensor and how a small camera could be that tiny. So this is all part of electronic engineering, where we work on how to design a chip, and then comes the next step, how to make it to a smaller size. So you have to look into electronic and computer engineering, and you will get an idea how these sensors are being designed. One question was, is there an option to override sensor? Yes, always currently, and I can say that majority of the time sensor will be designed in a way that you can override them. They are designed IoT application to help us to do tasks for us, and they will do what we will tell them to do. Okay, when we will be all the devices connected to internet, we as a human right now, I guess we have 7 or 8 billion population on Earth, and it is estimated that 4 billion of us are for somehow connected to internet. Um, IoT devices currently, they are around 10 billion IoT devices connected already on the internet. There are many predictions about saying that there would be 50 billion devices connected by 2025, or maybe over 80 billion. Things are improving, and that's a part of continual evolution which is happening at the moment. And there is a good chance that more and more devices will appear. I already mentioned they have overtaken us the number of human connected on internet. Number of devices is almost more than twice, and they will keep growing. Okay, if I want to relaunch, I'm not, because of time, I'm not going to relaunch this poll, but I hope if I have to relaunch this poll, I have managed to change the opinion of many of you in terms of what the Internet of Things is and how it is more frequent what we use than we think. And maybe hopefully the answer of many of you would have changed from I don't know to I'm using it every day, or I'm using it quite often than I initially thought. Last thing, I guess I thought this would be a good interest for you. There is an IoT comic book available online, free to download for you. It was work done with some of colleagues in Denmark. They have developed this IoT. I was also involved in this project later on. It's free to download. What it does, it just